Assalamualaikum and a very good day to you all. In this video, I would like to share with you the rules of differentiation. So let's get started with the first one. Okay, basic rule. So there are two of them. First, if k is constant, then the differentiation of k in terms of x is 0. Okay, and then next, if we differentiate x to the power of n in terms of x, okay, notice that x is the base, okay, the variable that we want to differentiate it with is the base. Okay, so what is the rule is that we copy the power and put it in front as a coefficient, and then we copy paste the x with the power less by 1. Okay, so this is basic rule. So maybe we can we try two examples. Okay, so the first one, let y equals 3. So dy dx is the differentiation of 3 in terms of x. Okay, therefore 3 is becomes 0. Okay, and next one is y equals x power minus 2. Okay, so the differentiation of y in terms of x is this one minus 2. We move the power in front, this one, and then copy paste the x with the power less by 1. Okay, and then minus 2x minus 3. Okay, so this is the differentiation lah. Okay, so this is the first one, basic rule. So let's move on to the second one, sum rule. Okay, if we have u, which is a function f with in terms of x, and v as a function of g in terms of x, then the differentiation of u plus v, it means the sum of the two functions in terms of x is the same as we differentiate u first, okay, and v first individually, then we add the mark. Okay, so this is the rule lah. This rule also applies when we are subtracting the function as well. Okay, so for example, if we are going to differentiate, okay, if we are going to differentiate x squared plus 3x, okay, so this one one function, this one another, and then we have addition between them, so we can differentiate x squared in terms of x, and then differentiate 3x in terms of x, in terms of x, then we add the mark. Okay, so 2x plus 3. So this is the answer. Okay, so this is sum rule. Okay, so next we move on to product rule. Okay, so what we have here, more or less the same thing, two different functions. Okay, but unlike the last one, this one what happened is that the first function is multiply the second function. So for product rule, it's a little bit different. It is we have to differentiate the first function, then we multiply with the second, plus then the first function multiply by the differentiation of the second function. Okay, so it's like this. Since u is f, so differentiate dx fx, okay, multiply by v is gx, plus u multiply differentiation dx v is gx. Okay, so differentiation of fx in terms of x is f prime, and then multiply by gx, plus u multiply by g prime x. So we have maybe I put gx in front, gx multiply f prime x plus u. Oh, I haven't replaced u yet, sorry. So u is fx. Okay, fx. Okay, so it's fx g prime x. So just get rid of it, put lah in front, same thing also. Okay, so this is product rule. Okay, and next, one example lah. Okay, let's consider, let you, no need lah to let. Okay, so maybe y equals 3x minus 2 squared 2 minus x 2 plus x to the power of 3. Okay, so dy dx is just the very thing that I just said. Okay, multiply with the second one plus the first one, multiply the differentiation of the second one. So we just key in the bracket 3x minus 2 squared 2 plus x cube 3x minus 2 squared 2 plus x cube plus x cube. Okay, then we proceed. So differentiation of 3x minus 2 squared is, this is by using power rule. Power rule we will cover later, but I just do it over here first. We bring in front 3x minus 2 power less by 1 multiply by differentiation of the inside. Okay, and then multiply 2 plus x cube plus 3x minus 2 squared. This one more or less the same thing, we multiply 3 and then copy paste the bracket with power less by 1 and then multiply with the differentiation of the content, the bracket. Okay, so for this one we solve them. So 3x minus 2 minus 1 is 1, this one multiply 3 and then multiply 2 plus x cube and then plus this one 3x minus 2 squared, 3 put in front here lah, wait, ayalah, 2 plus x squared multiply by 1. Okay, so we can simplify it further. This one 6, 3x minus 2 plus x cube plus 3x minus 2 squared 2 plus x squared. Okay, so this is the answer. Okay, I think I forgot to turn the notification. Yes, good. Okay, now so this is the answer, yeah. Okay, let's move on to quotient rule. Quotient rule, so quotient rule is it's just the same condition. We have two different functions, but unlike product rule, quotient rule is the difference with quotient is that we divide the first function by the second function. Just now is if it's product, then u multiply v, right? So product is u divide by v. So that's the difference lah. Okay, so if we have a fraction function, then the numerator is u and the denominator is v. Okay, so this is the numerator, this one is the denominator. Okay, so how we are going to do this? It's easy. We just differentiate the front function, the top function, which is u, and then we multiply by the v, and then we minus. Okay, we minus with u multiply the differentiation of v, the second function. Then we divide everything by the square of the denominator. Okay, so when we substitute u with fx and so on, so we have d dx fx multiplied by gx minus fx d dx gx. okay, and then divides by gx squared. Okay, and then so this part will be f prime. Okay, and then just put gx next to it, means multiply, and then fx, we differentiate gx in terms of x, we get g prime x divides by gx. Okay, so this is the form. Okay, so maybe one example, y equals 1 minus x over x squared minus 3. Okay, so for this one, dy dx, so the numerator is u, okay, and then denominator is v. Okay, so dy dx is just the differentiation, the differentiation of the top one multiply the numerator, differentiation numerator multiply denominator minus numerator multiply by the differentiation of denominator, and then we square the denominator. So what is the numerator? Numerator is 1 minus x, 1 minus x. Denominator is what? X squared minus 3, x squared minus 3, x squared minus 3. Okay, I just maybe it's a quick tip. Don't bother to expand this one. Okay, you will end up waste your time. Okay, so let's proceed. So differentiation 1 minus x is minus 1 multiplied by x squared minus 3. Okay, and then minus 1 minus x. Differentiation of this one is 2x. Okay, right. And then divide this one lah, as I said, no need lah. Just leave it like that, yeah. So maybe it's better if we expand this whole lot. Maybe we can solve them. Maybe you can simplify it further. Minus 1 plus x. Sorry. Multiply already lah with that one. So minus 2x plus 2x squared. See? There's something we can simplify. Okay. Now, for this one minus x squared plus 2x squared. So what we have is x squared minus 2x plus 3 divides by x squared minus 3 squared. So this is the differentiation of fx, yeah. Fx, sorry. This is the differentiation of y in terms of x. Okay. Next is power rule. Okay, power rule is the one that I've just demonstrated to you guys, but I'm going to repeat it anyways. Power rule means it must be some function that has another power of n. Okay, actually power rule is like a basic rule whereby you have x to the power of n, whereby if you differentiate this in terms of x, what we do is we bring the power in front. So n will be the coefficient, and then we copy paste the x with the power less by 1. Okay, but the difference with the power rule is that since the base is a function, unlike this one is a variable, one thing, this one is a function, the whole function, so it's not just x. Okay, must be some numbers or some things inside it. So what should we do is that we bring n from the power to become the coefficient. Okay, that's the first thing, which is equal this one lah, more or less the same. Next, we copy paste everything, which is the fx itself. Okay, with the power less by 1. Don't forget, And another thing is that, this one multiply lah. Okay, and is that we must multiply by the differentiation of the bracket. In this case, the content of the bracket is the fx. Okay, so I'm going to rub this off. Good. And then we continue. Now, n and differentiation of this, I rearrange. So, n f prime x bracket fx n minus 1. So, this is the differentiation of power rule. So, one example, actually so many examples already previously I show you accidentally, but we are going to do one lah, by the way. Let's see, 3 minus 4x squared to the power of 7. Okay, Now, the differentiation of y in terms of x is that the 3 just is a constant, so just bring lah. Okay, and then we copy paste. No need, not yet. The power, right, bring in front. So 7 multiply, not 37. And then next we copy paste. Copy paste what? The whole thing. Okay, with the power less by 1. This one don't forget. Okay, and then we multiply with what? Hijau pula. Different lah, blue lah. Okay, then we multiply with the differentiation of the power here. Copy here. So 3 minus 4x square. Okay, so 3, 7 is 21. 3 minus 4x squared to the power of 6. We differentiate this one, we get minus 8x. Okay, and then we multiply this one. We can make it nicer by multiplying minus 8 by 21. Sudah berapa pula ni? 16 lah. 16. 168. 168. 168 minus 168x 3 minus 4x squared to the power of 6. So this is the differentiation. Okay, and last but not least, chain rule. Okay, chain rule is whereby we have two functions y. Okay, this one a little bit different. Previously we have function f in terms of x, right? This time we have function f in terms of v. Okay, and then we have v in terms of x. Okay, and then correct or not? Looks like it's not correct. Oh, wrong. I made a mistake. It's supposed to be v as well. Okay, and then this one is x. Okay, sorry. Okay. Okay, so y is f, a function in terms of v, and x is a function of g in terms of v. So what we are how we are going to get dy dx? It's simple. It's dy dv multiply dv dx. Okay, so why it's called chain rule? Because the element here must be chained to this one. It means that there must be some common difference of v. Okay, so for example, if you want to get dy dx, but we have dy in terms of t, so we must get dt in terms of dx. So this one, the common variable or common difference is t. So that's what it means by chain rule. Okay, so maybe we can have one example. Okay, let y equals 4 v squared minus 3v. Okay, and then x equals 2 minus 3v. Okay, so how to get dy dx? We differentiate these two first. Okay, so from here dy we get dy dv, which is 8v minus 3, while this one we can differentiate x in terms of v, which is minus 3. Now, so from here we can figure out to get dy dx by multiplying dy dv by dv dx. Okay, so from here we have dy dv. Ganti already lah. Okay, 8v minus 3. Remember, there are two terms, put bracket. Okay, otherwise we will make mistake. Always, most students will make this mistake. But the problem is, we have dx dv. But the one we need in our cycle, okay, our chain cycle, sorry. our chain is dv dx. So how we're going to get dv dx from dx dv? It's very simple. We just turn this upside down. Okay, if we turn this upside down, this one also we have to turn upside down. So dx dv can be turned as dv dx with the condition the minus 3 is 1 over minus 3. So there we go. Our dv dx we can ganti over here. We can substitute. So multiply by 1 over minus 3. Okay. Therefore we get berapa ni? 8v. Oh sorry. Negative 8v over 3 plus 3 over 3. Correct. And then we have minus 8v over 3 plus 1. So this is our dy dx. Okay. Please do notice when we are doing chain rule, even though this is x, dy dx, our function still in terms of v. That is why we call it chain rule. It's a little bit different from the first 5. Okay. I think that's all. Thank you for your time and attention. Assalamualaikum. Have a good day.